Hello and welcome again to our other series of mathematics lesson. We are continuing with the topic right angle triangles. In our past lesson we made an introduction on what Pythagoras Theorem is and what it states, where we were able to say that if you have a right angle triangle, this shorter side is called the base of that particular triangle. This will be the opposite to this particular angle and we call it the height, and this will be the hypotenuse. In most cases we normally call it a C. Now Pythagoras theorem says that when you square, you get the sum of the squares of the two shorter sides, it will be equal to the sum to the square of the longer side. That is, if we take h squared plus b squared, the result will be equal to c squared. We are also able to use the Pythagoras theorem to find the given length of a right angle triangle, be it the longer side or be it the shorter sides. Like for instance, if you are given a right angle triangle where you are told that the longest side is 5 units and one of the shorter sides is 3 units, we can be able to get this other side that you are not given, because when we use that Pythagoras theorem, we can be able to highlight or find this other shorter side. That is, when you take a squared plus 3 squared, it must give you 5 squared. That means that a squared will be equal to 5 squared, which is 25, subtract 3 squared, which is 9. When you do that, you'll get that a squared is equals to 16, and for you to get the value of a, you have to find the square root of both sides. That means that a will be equal to 4 units. We're also able to use Pythagoras theorem to solve 3D problems and 2D problems. Today, we want to advance and introduce what we call the trigonometric ratios. Now, whenever we have a right angle triangle where this side is A, this side is B, and that other side is C, we normally have an angle formed here called an angle theta. And if this is theta and this is 90 degrees, because it's a right angle triangle, we can also be able to get that particular angle. This angle and this angle add up to 90 degrees. Therefore, you to get this upper angle that you're not given, you'll take 90, you subtract the theta that you have been given. Now, depending on the existence on the sides of this particular triangle, these sides will have different names. Like in this case, given that this is the angle theta, we have this side that is opposite to this particular angle. This side is normally called the opposite to angle theta. But in case you're talking about the opposite to angle 90 minus theta, then this one will be the opposite side. Again, to this particular angle, part B is adjacent to this particular angle, and therefore this side B will be called the adjacent to that particular angle. Then, of course, the longest side of a right angle triangle will remain to be called the hypotenuse. Now, these are the names that we are going to adopt: opposite, adjacent, and hypotenuse, as compared to when we are using A, B, and C when we were using the Pythagoras theorem. Now, we can be able to get different ratios for this particular angle theta. It will be important at this particular point to mention that the application of these trigonometric ratios was wide, especially in the ancient Egypt during the construction of the Egyptian pyramids. For the stability of those pyramids, a lot of calculations were made based on the use of the trigonometric ratios. Also, in astronomy, we normally make good use of those particular trigonometric ratios. Given that this is a right angle triangle that is 90 degrees, and our theta or angle theta is at the top, then we can be able to come up with the names of the sides of this particular triangle depending on the position of our angle theta. Now in this case, the side that is opposite to angle theta is this side down there, and therefore this will earn to be called the opposite side of angle theta. Adjacent to this angle theta is this particular side, and therefore it will be called the adjacent side, normally denoted by capital A. This is normally denoted by a capital O. Then of course the longest side of a right angle triangle will remain to be called the hypotenuse. In this case we refer to it as capital H. Now there are three main trigonometric ratios that we are going to introduce. That is the things to do with sine, cosine, and tangent. Given our right angle triangle still, where that is 90 degrees, and this is the angle theta, this side will be the opposite to the angle theta. This will be the adjacent to the angle theta, and of course this side will be the hypotenuse or H to the angle theta. Now I've said that the three trigonometric ratios are sine, cosine, and tangent. Sine is normally shortened to sine, cosine is normally shortened to cos, and tangent is normally write it in short as tan. Now in this particular case, if we want to get the sine of this angle theta, then we use those particular ratios, the opposite, adjacent, and also make use of the hypotenuse. In this case, if you want to get the sine of theta, then you'll have to take the opposite, that is O, you divide by the hypotenuse, that is H. And if you want to get the cosine of theta, that is cos of theta, then you take the adjacent side, you divide still by the hypotenuse. This is A, this is H. And then finally, if you want the tan of theta, it will be given by opposite, which is O, divided by the adjacent side to that particular angle A. In this particular case, we can make a summary of what all this entails. You can be able to see that if you're talking about sine, sine is opposite all over hypotenuse. And that will give us the first acronym, that is SO, meaning sine is equals to opposite all over hypotenuse. The next one is on cos. Cos theta is equal to adjacent all over hypotenuse. In this particular case, we have C, we have A, and we have H. Then the last one, we have tan theta. Tan theta is opposite all over adjacent. That is T is equals to O all over N. So this is the acronym that we normally use for you to be able to actually memorize how you can be able to get the sine, cosine, and tangent easily. That is so, ka, toa. For you to get sine, you take opposite of that particular triangle, you divide by the hypotenuse. For you to get the cosine of that particular angle, you take adjacent, you divide by the hypotenuse. And then for you to get the tangent, you get the opposite, you divide by the adjacent side. Example. Label the sides, label the sides as opposite to angle theta and adjacent to angle theta in the triangle below. We have a right angle triangle. We are given that this is our angle theta. We are supposed to mention or label as either opposite or adjacent side of this particular triangle in respect to our angle theta. We had said that the side that is directly opposite to the angle will be referred to as the opposite side of that particular triangle, while the side that is adjacent to this particular angle will be referred to as the adjacent. So this is the adjacent side of this particular triangle. Sometimes it is also important for you to be able to know the longest side. The longest side of this particular triangle is this side, and it's referred to as the hypotenuse. So that is it. Opposite to the angle, adjacent, then hypotenuse. Supposing that this angle theta was on this side of the triangle, then in this case the side that is opposite to that particular angle is this side, and therefore this will be the opposite side. The side that is adjacent to this angle is this one on top, and therefore this one will be added to be called the adjacent side of that particular triangle. This will continue to remain to be the hypotenuse because it is the longest side of that particular triangle. Example 2. With trigonometric ratios, in fraction form, for each of the following triangles. So we are supposed to write the trigonometric ratios in fraction form of each of the following triangles. Triangle number 1, we have a right angle triangle. This is the angle theta. The base is 5 units. The hypotenuse is 7 units. We are supposed to write the 3 trigonometric ratios in fraction form for this particular triangle. Now it is important for us to be able to get the side of this particular triangle. Now given that the hypotenuse is 7, the base is 5, we can be able to get the height of this particular triangle by use of Pythagoras Theorem. In that particular case, our height, which is the unknown, will be given by the square of the hypotenuse, which is 7 squared, subtract the base squared, then you find the square root. This will be 49, subtract 25, we get the square root, and this will give us the square root of 24. We can leave it in third form, that is the root of 24. Now we want to obtain the three trigonometric ratios of this particular triangle with respect to this particular angle theta. We had said the three trigonometric ratios are sine, cosine, and tangent. We had said that sine of theta will be equal to the opposite all over the hypotenuse. And in this case, the opposite to this angle is root of 24 over hypotenuse, which is 7. The question requires us to leave our trigonometric ratios in fraction form, so we can leave it in that form, that is root of 24 all over 7. Cosine of theta, that is cos theta, will be given by adjacent all over the hypotenuse. Now in this case, our adjacent to this angle theta is this base, which is 5. You divide by the hypotenuse still, which is 7 units. And in that case, our cos of theta will be 5 over 7. Finally, we need to get the tangent to the theta of this particular triangle, and therefore tan theta will be given by opposite all over adjacent. And in this case, the opposite to this angle theta is root of 24 over the adjacent, which is 5. So that is how we can be able to find the three trigonometric ratios when you are given such a triangle. Always ensure that you have the three sides of that, the measurements of the three sides of that particular triangle. This was 7, this was 5, therefore you can be able to use Pythagoras Theorem to obtain the length of the opposite side to this angle. Then from there, we use the SOHCAHTOA to obtain the trigonometric ratios of the sine, cosine, and tangent. Sine has given us root of 24 all over 7. Cos of theta has given us 5 over 7. And then tan of theta has given us root of 24 all over 5. Part B, we have a right angle triangle, again of this form. We are told that that is 4 units. The angle that you're talking about is the angle theta there. Then we have been told that the hypotenuse is 9 units. Again, it is important for us to get this side that has not been mentioned. So in this particular case, we can be able to obtain it by subtracting the square of the shorter side from the square of the hypotenuse, then we find the square root. In this particular case, this side shall be the square root of 9 squared, which is 81, subtract 4 squared, which is 16. That one will give us root of 65. So we can be able to leave it in third form. Again, for us to obtain the trigonometric ratios, sine theta, now side to this angle, will be given by the opposite to this angle, which is 4. You divide the hypotenuse of that particular triangle, which is 9. Cos of theta will be given by adjacent divided by the hypotenuse. Adjacent to this angle is root of 65 divided by the hypotenuse again, which is 9. And then finally, if you want to get the tan of theta, will be given by opposite all over adjacent, and therefore tan of theta will be equal to opposite. Opposite to this angle is 4 divided by the adjacent, which is root of 65. So that is how we can be able to obtain the three trigonometric ratios out of this particular triangle, so long as you know how to obtain the side that you have not been given. So sine will be opposite all over hypotenuse, which is 4 over 9. Cosine will be adjacent all over hypotenuse, which is 9. And then finally the tan of theta will be opposite of that particular angle divided by the adjacent, that is opposite all over adjacent, which has given us 4 all over 65. Part C. Part C, we have a right angle triangle at that particular place. This is our angle theta, degrees, and this side you have been given 3 units. This side is 5 units. Again, it is important for us to use Pythagoras Theorem to obtain the length of the longer side of this particular triangle. Therefore, our hypotenuse will be the sum of the squares of the two shorter sides. In this case, this will be the square root of 5 squared plus 3 squared, which will be the square root of 5 squared is 25, 3 squared is 9. Therefore, 25 plus 9 will give you 34. Therefore, that means that our longest side is the root of 34. In third form, we leave it that way. So in getting the three trigonometric ratios, we use our acronyms, SO, CA, TOA. Therefore, sine of theta will be given by the opposite all over hypotenuse. Opposite to this angle is 3. That will be 3 all over hypotenuse will be the longest side, which is root of 34. Cosine of theta, which is the second trigonometric ratio, will be given by adjacent divided by hypotenuse. And in this case, our adjacent to this angle is 5. You divide it by the hypotenuse, which we got it to be root of 34. Then finally, the tan of theta will be given by opposite all over adjacent. And the opposite to this angle is 3. Its adjacent is 5. So that those are the three trigonometric ratios we can be able to obtain from this particular triangle. Note that the sides of that particular triangle will be named depending on the relationship of those particular sides to the given angle. And as I said, if this is 90 degrees and this is theta, then because the three angles of a right angle triangle must consist of 180, then you can be able to get this angle by subtracting theta from 90 degrees. And it will give you this particular angle. So sometimes you can be asked to get the trigonometric ratios that is in relation to this particular angle, 90 minus theta. That is how you can be able to express them. Example 3. A vertical flag flagpole casts a shadow that is 20 meters long. We are told that if the pole is 15 meters high, find the ratio of one trigonometric ratio, that is tan theta. In this case, we have the pole, that is the ground, that is the flag. We have been told that the flag is 15 meters high and it is casting a shadow which is 20 meters long. We are supposed to get this angle theta in relation to one of the trigonometric ratio, which is tan theta. Now we understand that from the relationship SOHCAHTOA that our tangent or tan of theta will be given by opposite all over adjacent. Now in this particular case, in relation to this angle theta, this side will be the opposite to this particular angle, this side will be the adjacent, and of course the other side will be the hypotenuse. And because we are only interested with one of the trigonometric ratio, that is tangent, then you take the opposite, which is 15 meters, you divide by the adjacent, which is 20 meters. Of course, meters and meters will cancel off. Then when you simplify, 5 goes there 3 times, 5 goes there 4 times. That will give us 3 over 4 as the trigonometric ratio. Tan theta is equals to 3/4. In future, we shall be seeing how we can be able to convert these particular trigonometric ratios back to angles so that we're able to get what exactly this angle theta is. So after looking at that, we now want to begin calculation on how we can be able to find the unknown sides of a triangle by making use of the trigonometric ratios. That is, finding the unknown sides. Now, trigonometric ratios can be applied in finding the unknown sides of a particular triangle, so long as you know how to make or how to manipulate the 3 trigonometric ratios by use of SOHCAHTOA, you can be able to obtain or find the side of an unknown angle without the use of Pythagoras Theorem. We are going to consider a number of calculations or a number of examples for us to be able to solve or to find the unknown sides of a triangle. And in this particular case, we are going to make use of calculators, and the main thing that you'll consider when you want to use the calculator is that always ensure that your calculator is in degree mode, or you have resetted your calculator from all the other settings to read degree mode for you to be able to obtain the sine of the sine, the cosine, or the tangent of particular angles. If, for example, that is the right angle triangle that you have been given, we don't know what this side is, then you have been told that this side is 3 and that this particular angle theta is 30 degrees. At this particular instance, we can be able to use a calculator to be able to, and the trigonometric ratios to be able to solve for x. Now get that this particular angle is opposite to this particular side, and this is the hypotenuse side. Therefore, the trigonometric ratio that you're going to use should consist of an opposite and a hypotenuse. And in this particular case, it is obvious that we are going to use the first trigonometric ratio, which is sine, for you to be able to obtain the opposite side, because sine of theta is given by opposite all over hypotenuse. In this case, our opposite is x, In this side, our theta is 30 degrees. So that will be a sine of 30 degrees is equals to the opposite, which we do not know. It's a pronumeral x all over the hypotenuse, which is 3. From this particular case, you can now be able to get the value of x by multiplying both sides by 3. If you multiply this side by 3 and the left hand side by 3, you'll be able to get that x will be equal to 3 sine 30. Now we had said that always ensure that your calculator is in degree mode before you can be able to use it in finding angles. So you press the sine of 30 from your calculator, it will give you 0.5. You multiply that 0.5 with 3, that will give you that x will be 1.5 units. And in this particular case, we can be able to put there 1.5 units. If we have a right angle triangle of that form, where you're given that this is 42 degrees, and that this is the pronumeral that we do not have, and this other side is 7.2 units, again, we can be able to obtain this particular side. Remember that that is the opposite side, which we are not interested with. This is the hypotenuse side, and this is the adjacent side. Because we already have the hypotenuse and we need the adjacent, therefore we're going to use a trigonometric ratio that has an hypotenuse and an adjacent on its ratios. And that means we are going to use cosine as a trigonometric ratio to assist us solve for x. In this particular case, the cosine of theta will be given by adjacent all over the hypotenuse. Our theta is 42 degrees, so cos 42 degrees will be equal to adjacent, which is x, or which we do not know, divided by the hypotenuse, which in this case is 7.2. And therefore, you to get x, you'll have to multiply both sides by 7.2, 7.2. X therefore will be 7.2 multiplied by cosine of 42. Again, we begin by pressing cosine of 42 from your calculator, which gives you 0.74. You multiplied by 7.2, it will give us that x is 5.350642743 units. And you can be able to round it off to the given number of decimal places, irrespective of what the question requires you to do. So in this particular case, when we need the adjacent and we've been given the hypotenuse, then we make good use of the trigonometric ratio cosine. Finally, when do we make use of tangent? Given that this is our right angle triangle and that side is x, this angle here is 71 degrees, and that we have been given this side to be 4 degrees, 4 units, we can be able to obtain the value or the measurement of that pronumeral x, which we have not been given. In this particular case, this angle is opposite to that side, and therefore this is the opposite side to the angle. We have been given this side, which is adjacent to this particular angle, and of course that is the longest side, which is the hypotenuse. Now we want to make to obtain the value of x. Therefore we choose a trigonometric ratio that has an opposite and adjacent in its ratios, and therefore that means we are going to make use of tangent, because tan of theta is given by the opposite divided by the adjacent of that particular angle. Now in this case, our theta is 71 degrees, so that will be the tan of 71 degrees is equal to the opposite, which we do not know, which is x. We divide it by the adjacent side, which is 4 units, and therefore for us to be able to get the value of x, we'll multiply both sides by 4. Therefore, x will be 4 multiplied by the tan of 71 degrees. So from your calculator, again you press tan of 71, you'll get 2.9042. You multiply by 4, which will give us x to be 11.61684351 units. Therefore, this particular opposite sides will be 11.61684351 units. Now again, depending on the number of decimal places or the significant figures, the question will require you to round off your answer. Then you should be able to do that. So that is how we can be able to make good use of the three trigonometric ratios to find the sides which are unknown. Now sometimes you may not find exact degrees, because at some cases you might be asked to use the trigonometric ratios to find a given angle. In finding angles, they are normally measured in terms of degrees, minutes, and seconds. For example, if you have 71 degrees followed by 30 minutes, for example, and then 30 seconds. So this small dot or small circle above the angle denote a degree. A small comma on top denote a minute, and two small commas on top denote seconds. Now it is important to note that 1 degree is equivalent to 60 minutes on when you preferably when you want to convert. So for example, in this case, 30 degrees or 30 minutes is equivalent to 0.5 or a half degrees, going by this particular calculation. Examples. For each of the following triangles, find the value of x, find the value of x correct to 2 decimal places. Part A, we have that right angle triangle where this side is x units, that is 7 units, and this angle here is 38 degrees. Now for us to be able to get the value of x, we are going to use a trigonometric ratio that consists of opposite and hypotenuse. That means we use so. That is the sine of theta, which is now 38, is equals to the opposite, which is x, all over 7. That means that for us to get x, you have to multiply x on both sides, and therefore x will be equal to 7 multiplied by sine of 38. So we press sine of 38 on the calculator, then you multiply it by 7, it will give you that x is 4.309630327 units. The question requires us to write our answers correct to 2 decimal places. So that means that our x will be equal to 4.31 when rounded off to 2 decimal place. Part B, we have a right angle triangle of that form where this angle is x, this angle here is 42 degrees, and you have been given the adjacent side to be 4 units. So we want to make good use of a trigonometric ratio that has the opposite and the adjacent. Opposite and adjacent, that means we are going to make use of tangent, and therefore tan of theta, which in this case is 42, is equals to opposite, which is x, all over adjacent, which is 4. And therefore our x shall be equal to 4 multiplied by tan of 42. So you press tan of 42 from your calculator, then you multiply it by 4. It will give you x to be 3.6016161777. Again, the question requires us to write our answers correct to 2 decimal places. That means that our x shall be equal to 3.60 units. Finally, number C, we have a right angle triangle of that form where you have been given this side to be x, the longest side to be 10 units, and this angle to be 24 degrees. For you to be able to obtain the value of x, we need x is adjacent to the angle theta, and 10 is the hypotenuse of that particular triangle. So for us to be able to get the value of x, we need to make use of a trigonometric ratio that has adjacent and also hypotenuse. That means we are going to use cosine because it has adjacent and hypotenuse, and therefore cosine of theta, which is 24 degrees, is equals to adjacent, which is x, all over the hypotenuse, which is 10. For us to get x, we multiply both sides by 10. That means that our x shall be equal to 10 multiplied by the cosine of 24 degrees. So we get the cos of 24 degrees from the calculator and multiply it by 10. That means that our x shall be 9.135454576 units. The question requires us to write our answers correct to 2 decimal place. That means our x shall be equal to 9.14 units. Final example on how we can be able to use the trigonometric ratios to solve for the unknowns. That is example 2. We are told that Amy walks 5.4 meters up a ramp for 5.4 meters up a ramp that is inclined at 12 degrees horizontal to the horizontal. To the horizontal. How high? How high? Correct to 2 decimal places. Correct to 2 decimal places is the ramp above her starting point. Above her starting point. Now we have the wall, then we have a ramp in which Amy is walking through. So he has walked 5 from this particular point to the top, that is 5.4 meters along that particular ramp, and we have been told that on the horizontal that particular ramp has been inclined to 12 degrees. We are supposed to find to the nearest 2 decimal places how high is she above her starting point? Her starting point was here, and therefore above her will be equivalent to this particular side, which is the opposite to this particular angle. So if we find this particular side, we'll have been able to find how high Amy will be above her starting point. And that tells us that we must use a trigonometric ratio that has an opposite and a hypotenuse. In that case, we are going to use sine. Therefore, sine of theta will be equal to the opposite all over hypotenuse. In this case, our theta is 12, so that will be the sine of 12 degrees is equals to the opposite, which we do not know, all over the hypotenuse, which is 5.4 units. Therefore, for us to be able to get x, we multiply both sides by 5.4, and therefore x will be equal to 5.4 multiplied by the sine of 12. So from the calculator, sine of 12 will give us 0.207. We multiply by 5.4, it will give us x to be 1.122721313 meters. The question requires us to write correct to 2 decimal place. Therefore, Amy is 1.12 meters above her starting point, 1.12 meters, which is equivalent to that particular side, which is the opposite. Now this brings us to the end of these two subtopics, one on the use of on the three trigonometric ratios, that is sine, tangent and cosine, and how we can be able to use the three trigonometric ratios to find the sides of the unknown. Thank you.